So good morning, everyone. I'm Dr.Sangeetha, Professor, Department of Pharmaceutics, SRM College of Pharmacy, SRMIST, Kattankulathur. And thank you all for the opportunity. So now I'm going to present on the topic optimization of gastric residence time, enhancement for famotidine via Raft-Forming drug delivery system, a design experimental approach. Coming to the introduction part, so gastroesophageal reflux disease occurs when the gastric contents or bile irritate the esophagus, causing discomfort and the reflux of acid fluids from the stomach. So currently available treatments for gastroesophageal reflux disease includes antacids, which neutralize stomach acids such as H2 blockers and proton pump inhibitors. These medications cannot prevent the reflux of stomach contents into the esophagus. Raft-forming drug delivery systems represent an innovative oral control drug delivery approach. When these systems come in contact with gastric fluid, they gel and form a thick porous layer on the stomach. RFDDS are liquid at ambient temperature but undergo gel formation due to cation-induced gelation and temperature-dependent properties. Raft formation can occur through physical mechanisms involving swelling, diffusion, ion cross-linking, and physiological stimulus based on the pH and the temperature. So the drug we have used here is the famotidine, which comes under the category of anti-ulcer. It is an H2 receptor antagonist, and the bioavailability of the drug is about 40 to 50% only, and the half-life is 2.5 to 3.5 hours. So we have cited this drug. The aim and objective of the study is to investigate the raft-forming suspension of famotidine as an anti-reflux formulation to improve the oral viability of narrow absorption window drugs by enhancing gastric residence time (GRT) and preventing gastroesophageal reflux disease (GRD). The objectives of our study is the main thing to find a suitable polymer for RFDDS, the delivery system, to enhance the GRT of famotidine and enhance the bioavailability. So these are our main objectives. And as to initiate this study, we have started with the pre-formulation studies where we have checked about the physical appearance of the drug, the solubility study and the identification tests of the drug. Then, of course, UV spectrophotometer studies, the lambda max, we have checked it, the loss of drying, the particle size determination we have done, the drug and exhibit compatibility studies we have done. Then compatibility study was done through the FDIR also. Then calibration curve of famotidine was also being developed. The preliminary screening includes such as the 4 different raft-forming agents like sodium alginate, guar gum, xanthan gum, and carbapol were used in the combination to select a good raft-forming agent. And a total of 6 formulations were prepared and evaluated for in vitro gelation time, the floating time, and the ANC, of course. So the formulation table is being represented here, where we undergo the various polymers, such as we have the sodium alginate and xanthan gum and the guar gum. 3 different polymers we have been used over here in different formulations. So totally 9 formulations we have come up with. And this is the preparation method. That is how the drug preparation is being done, or the formulation, the raft forming of the suspension is being done. So here the drug and the excipients are weighed initially and transferred to a vessel and sterilized at 60 degrees centigrade. And the mucilages of the gums were prepared by the hydration method, that is addition of water. Then the drug dispersed in the purified water. Then micronize the other excipients with mortar and pestle. Then micronized excipients transferred into the beaker containing the water and stirred for about 1 hour. Then add drug the dispersion and the gum mucilage with the above step. Slow mixing, we have done it. And finally, preserve the sodium benzoate where added, so the preservative was added and the suspension was transferred into a amber colored bottle for further use. The optimization of the preparation was carried out with the 3-square factorial design. From the preliminary results, sodium alginate and guar gum are chosen for further studies using 3-square factorial design. The amount of sodium alginate and amount of guar gum were chosen as independent variables in 3-square full factorial design, while dependent variable were selected as in vitro gelation time, the raft weight, and the acid neutralization capacity. So these are our four different preparations we have carried out over here with the alginate, guar gum, sodium bicarbonate, then calcium carbonate, sodium chloride, sucralose, sodium benzoate, and additionally flavors also being used, and totally 9 formulations we have come up with. And the various evaluation tests such as carried out for this suspension of famotidine is in vitro gelation time, such as the floating lag time. Then we have a floating time, raft weight, then raft volume, in vitro drug release studies, acer neutralization capacity, in vitro permeation study, in vivo X-ray imaging study. So these all were carried out for our preparation. So to check out the compatibility, the IR studies were carried out, whether to check whether our drug is compatible with the selected polymers or not. The IR spectrum of famotidine exhibits a peak at 3402 cm due to the NH stressing of sulfonamide group, and peaks at 1286.55 centimeter and 1147.03 centimeter due to SO stretching confirms the drug that is a selected drug is the famotidine, and there was no mixing or appearance of new peaks indicating there is no compatibility problems with the selected drug and the polymers. So these are our results after preparation which have been obtained. So all the results were seem to be fine, but out of this, F2 batch, F6 batch showed a better results when compared to the other batches. So the good drug content was observed, and also the good percentage release. So when we check out here, this F6 batch, it shows about more than 90% of release over a period of 12 hours was observed, and even the other parameters were also were acceptable, and so F6 batch was selected as the best batch for further studies. So here we have the best batch and the comparative study between the pure drug. So the pure drug has a bioavailability or in vitro release nature only about 6 hours, where only with about less than 40% it has been released. Whereas over 12 hours, our formulation has shown more than 90% of release. So batch F6 was taken further for our in vivo studies as shown over here. So this is the animal model, the rabbit model we have selected, and the drug was administered to the animal model, and this is in the empty stomach where there is no gelation is being observed. So this is the initial raft development after administering the drug, where because of the pH nature, the gelation is occurring in the stomach. And we have the at 12 hours also this raft is being stabilized in the stomach. So this indicates a good better results for our drug. So preliminary batches, the guar gum shows better in vitro floating lag time, raft weight, and acid neutralization capacity than other formulations. The results of optimized batch is F6. The amount of sodium alginate in guar gum cross-linking with calcium chloride and produce uniform raft development, and amount of sodium bicarbonate for critical floating, that is which porous structure formation of raft and neutralization is observed. F6 shows better raft development and acid neutralization capacity, and also very sustained drug release for a longer period of time. So these are the counter plots and response surface plot of acid neutralization and in vitro drug release in percentage in raft-forming suspension using sodium alginate and the guar gum. So in conclusion, to conclude the things, in conclusion, a famotidine suspension formulated using a raft-forming drug delivery system with the guargum and sodium alginate as the raft-developing polymer has been successfully developed. The inclusion of calcium carbonate and sodium bicarbonate as neutralizing agents further enhances the formulation. When the suspension comes into contact with 0.19 HCl, the drug release of CO2 triggers and formation of a floating raft with a desirable floating lifetime of 21 plus or minus 0.3 to 45 plus or minus 0.5 seconds has been observed. Optimization of the formulation was achieved using a 3-level 2 factorial design with the combination of guargum and sodium alginate, demonstrating improving floating lag time, pH, raft volume, raft weight, and acid neutralization capacity. The optimized formulation was able to release the drug effectively for a sustained period of 12 hours. Kinetic analysis revealed that the famotidine release from the rat-forming drug delivery system follows zero under kinetics, indicating controlled and prolonged drug release. The FTIR analysis confirmed no significant interaction between the drugs and excipients, ensuring formulation stability. The optimized formulation remained stable under accelerated conditions of temperature and humidity. The controlled release of famotidine from the sodium alginate and the guargum formulation exhibited a significant effect on the absorption window, leading to improved viability by extending the gastric retention time of the drug in the stomach. The in vitro drug diffusion results further support the enhanced drug release achieved with F6 formulation batch. The in vivo floating behavior study confirms the floatability of raft in the stomach for more than 12 hours. Overall, the development of a raft forming suspension using guargum and sodium alginate provides a promising approach for enhancing viability and optimizing the treatment of gastroesophageal reflux disease and the stomach ulcers. So these are some of my references, and thank you all for the wonderful opportunity given. Thank you so much, everyone.